These next examples will show us another way of using L'Hopital's rule. So let's look at this first one. So the limit as x goes to 0 from the right of x ln of x. Okay, so if we try to just calculate this limit, right, so the first thing you should always do when trying to calculate a limit is just plugging in the number. So if we look at this and we take the limit as x goes to 0 from the right of x ln of x, well, we can see the x part of this, so this will go to 0, okay, so we have 0 there. And then we're multiplying by what the limit of ln of x is as x goes to 0 from the right. Okay, so here you're actually going to see why this says from the right rather than just 0, right? So if you look at the graph of ln of x, it looks something like this. Okay, so if we look at this as x goes to 0, first of all, I'll point out that there's no part of the graph that lives to the left of x equals 0, right? That's why it's really saying this way, right? Only from the right, because there's no part of the graph over here. Okay, so as x goes to 0 from the right, we can see, okay, so as our x's get closer and closer to 0, our y values get smaller and smaller, right? So they take off downwards to negative infinity. Okay, so we actually end up with 0 times negative infinity. So here, you're left wondering, well, should the answer be 0 or should the answer be negative infinity, right? What happens when you take more and more negative numbers, multiply them by 0? Is this taking you to 0? Is this taking you to negative infinity? We're not really sure, right? So this is another example of an indeterminate form, right? 0 times infinity. Okay, so here is an opportunity once again to use L'Hopital's rule, and you can't quite use it directly because remember, L'Hopital's rule is only applied when you have a quotient, right? When you have a fraction, so a function above another function. So here we have a product of two functions, right? Not a quotient. So we can try to do something with this, right? So we can try to take this and write it as a quotient, and then we can use L'Hopital's rule on it. Okay? So the trick here is really to rewrite this as the limit as x goes to 0 from the right. And the trick is going to be to take one of these two terms and send it down into the denominator, right? So you can kind of see that's what this explanation was. Okay, so if you have two functions, f and g, you can take one of them and send it down to the denominator. Okay, and notice f of x divided by 1 over g of x, that's the same thing as this, right? So all of these are the same thing, okay? So here, we're actually going to send this x down to the denominator. Okay, so we're going to write ln of x divided by, and I'm not going to write x, but I'm going to write 1 over x, right? So if you think about it, dividing by 1 over x is the same as multiplying by the reciprocal of 1 over x, which is just x. Okay, so these two expressions, this and this, those are the same thing, right? So this expression and this expression are the same. Okay, but now if you look at this, if we try to take the limit, ln of x as x goes to 0, right? So that's still going this way. So that's still going to infinity, right? Actually negative infinity. And 1 over x, right? So now we're looking at where is this going? Well, as x gets closer and closer to 0, so I'm taking 1, dividing it by smaller and smaller numbers, so that's going to positive infinity. Okay, so this is going to positive infinity. So I get something like that, right? So look, now I have an indeterminate form that goes with L'Hopital's rule, right? I have infinity over infinity. Okay, so that means that I can use L'Hopital's rule to try to take this derivative, right? So we're going to do that. So this is equal to, and I'll write the little LH to tell myself that I'm using L'Hopital's rule here. The limit, so let me write that in black. So the limit as x goes to 0 from the right, derivative of ln of x, we said was 1 over x, divided by, so 1 over x, maybe let's write that, so this is the same as x to the minus 1, right? So when we take the derivative of that, it should be minus x to the minus 2. Okay, and if we try to simplify that a little bit, so this is the limit as x goes to 0 from the right. Okay, so I have the 1 over x, so I'll write it like that. And then the minus x to the minus 2 on the denominator, I'm actually going to send that x to the minus 2 up to the numerator. So here's that minus. And then I'm going to write, the x to the minus 2 up here, right? So I actually have this, okay? So then that is the same as, so let's go on to another page here. So this is the limit, so this is from the other page, right? As x goes to 0 from the right of minus x squared over x, right? That's what we had. So this is the same as the limit as x goes to 0 from the right of minus x. And then look, so now we can take the limit, right? So if I plug in x equals 0, I'm going to get 0. Okay, so that solves that first question, right? So this limit here, this first limit, that limit should be 0. Okay, and I encourage you to look carefully at what the algebra was that I did here, right? So you try to work out how I got from here to here. I explained it a bit, but I think probably you will have some questions about how I get from there to there. Okay, so try it out on your own and then let me know if you still have questions. So let's try this second example, right? So the limit as x goes to infinity of x to the 3 over 2 sine of 1 over x. Okay, so we're looking at, put a line here. So the limit as x goes to infinity of x to the 3 over 2 sine of 1 over x. Okay, so let's just check and make sure that's what it was. Yes, okay, perfect. So if we look at this, right, if we try to take the limit, as x goes to infinity, x to the 3 over 2, well, that's going to go to infinity. And then if we look at this term right here, right, so take it one little chunk at a time, right? So if I look at just the 1 over x, as x goes to infinity, 1 over x will go to 0, right? So this will go to 0. So then I'm looking at sine of 0, and sine of 0 we know is 0, right? So this is infinity times 0. This is another one of those indeterminate forms, right? So we don't know whether the answer should be 0 or whether the answer should be infinity. Okay, so which one of these wins, right? We don't know. So that means we really need to use L'Hopital's rule or come up with some other trick, but in this section we're going to use L'Hopital's rule. So first thing we're going to do is rewrite it so that we can use L'Hopital's rule, right? We can't use L'Hopital's rule when we have a product, right? So this is something times something else. We need a quotient, right? Something divided by something else. So we're going to write this as limit as x goes to infinity of, so I'm going to use sine of 1 over x divided by, and I'm going to write x to the minus 3 over 2. Okay, so notice if I rewrote this, right, and moved this to the numerator, it would just turn that into a positive and it would give me this exactly, right? So to go from this step to this step, I'm really just rewriting the inside here, right? I'm not doing anything with the limit. So now if I look at each piece and try to see what the limit should be, if I look at the numerator, we still have the 1 over x going to 0. So we still have sine of 0 here, which gives us 0. And then in the denominator, we have x to the minus 3 over 2, right? So if I'm thinking about this, so maybe I'll write it over here. So if I'm thinking about this term, right, this is the same as 1 over x to the 3 over 2. So if I'm thinking about where is this going as x goes to infinity, well, this is going to 0, right? So this term right here in the denominator should be going to 0. Okay, so this should be going to 0 and 0. So that means we can use L'Hopital's rule, right? So we're going to go ahead and do that. So this is equal to, and I'm going to write the little LH to remind myself I'm using L'Hopital's rule. So this is the same as the limit as x goes to infinity, and I'm going to go ahead and take the limit of the numerator. Okay, so note you're going to have to use the chain rule here, right? So the derivative of sine is cosine. So take the derivative of the outside, leaving the inside alone, and then multiply by the derivative of the inside. So 1 over x, that's the same as x to the minus 1. And when we take the derivative of that, it should just be minus x to the minus 2. Okay? Divided by the derivative of the bottom. So here we're going to use that power rule. So I'm going to pull the minus 3 over 2 forward, and then subtract 1 from the power, so that's going to give me minus 5 over 2. Okay? So now let's simplify a bit. So this is equal to the limit as x goes to infinity. And I've got cosine of 1 over x. This minus and this minus will cancel. Okay? And so let's see. So I have a minus 2 on top, and I've got a minus 5 over 2 on the bottom, right? So to combine those, maybe we'll do it over here on the side, right? So if we look at just this, this should be, so this should be x to the minus 2 over x to the minus 5 over 2. And that's the same as x to the minus 2 minus 5 over 2, right? You subtract the powers when you're combining these. And that's the same as x minus 2 plus 5 over 2. And if you do the combination in that exponent, so that should give you x to the 1/2, right? So we get something like that. Okay? So then over here, if we go back to the original problem here, we have this divided by, so we still have this 3 over 2 in here. And then we have this x to the 1/2. We'll put it in the numerator here, right? Because that's a positive power, right? X to the positive 1/2. So this is going to be x to the 1/2 in the numerator here. Okay, so let's rewrite that so it doesn't look so ugly. So the limit as x goes to infinity of, okay, so we have, I'm going to flip over this 3 over 2, right? So I'm going to have 2 thirds cosine of 1 over x, x to the 1/2. Okay, so now let's try to take the limit, right? Let's see what happens. Okay, so if we try to take the limit, the 2 over 3 is going to hang out there. So if we look at cosine of 1 over x, well, 1 over x, as x goes to infinity, this is going to go to 0. So we're going to be looking at cosine of 0. Right, so this is the same as 2 thirds cosine of 0. Okay? And then x to the 1/2, as x goes to infinity, is going to infinity. Okay? So now if you look at this, right, 2 thirds, cosine of 0 is 1, right? So this is really 2 thirds times 1 times something that takes off to infinity. So notice here, there's no dilemma here, right? It's not like 0 times infinity. This is just, you're taking really big numbers and you're multiplying by them by 2 thirds, right? But who cares? That's still really big numbers, right? So this is equal to infinity. Okay, so overall, this limit, right, so the limit as x goes to infinity of this function here should be infinity, right? So that turns out that takes off to infinity.